Hi everybody, welcome to another Chats with Chaudhry. I hope you're safe and well. It's a Monday morning here in Surrey and the sun is glorious. It's a bit cold, but it's a lovely day. And I'm delighted to join by Alan Hoffmeister, who is, and I have to read this because it's quite a long job title, a Senior Global Technology and Market Development Manager, Microbial Solutions at Charles River. And we're going to be talking about cartridge technology in the area of bacterial endotoxin testing, or BET for short. So Alan, how are you, my friend?
Good morning, Rizwan. Yeah, I'm doing well, and it's a beautiful day here in Herne Bay in Kent as well. So the blue skies and it's looking all right out there today.
Yeah, well, I have to say, just by saying the word bay, you suddenly make it sound far more exotic than me saying in leafy Surrey. I've got to say, so I'm a bit
Yeah,
jealous. You've got a bit more of a view than I have, I can say.
well, yeah. My office is in the garden, and so I've got a view of the lawn which I cut at the weekend.
All right, so let's talk about cartridge technology. But before we do that, perhaps for those people not familiar with Charles River, you give me a quick overview of Charles River and your role within that.
Yes, I can. So Charles River was founded in 1947 on the banks of the Charles River in Boston. So that's where the name comes from.
All
It's
right, okay.
people think it's the man, and they'll call up asking to speak to Mr. Charles River. No, it's the river. So that's the name, and we're a global research organization. So we specialize in working with drug companies to help them develop new drug products and therapies, basically. There's several different divisions within Charles River, and the division that I work within is microbial solutions. I should also point out that Charles River worked with about 80% of the new drug products that were approved by the FDA last year, and it will
Right.
probably be the same this year, including quite a few of the COVID therapies as well. But microbial solutions, we sort of focus on manufacturing support. So we have three brands within microbial solutions. So we have the Celsis brand, which is for rapid microbial detection. We then have the Acugenics brand, which is accurate microbial identification using 16S gene sequencing and then mass spectrometry through a MALDI-TOF system. And then finally, there's the endotoxin side of the business, which is Endosafe, and that's where my expertise lies. So as part of the technology and market development team, and I'm sorry about the length of the title, it even causes me problems, I tell you. But what we do is we basically are involved in introducing new technologies to the market that we've developed. We work with our product management teams, our commercial sales teams. We bring information back from the marketplaces to our product management teams so that they can develop products and offer general support as well to our client base. So it's a pretty varied role, and it gets me about a little bit.
Right. Well, I wonder if yeah, well, that's a good point because obviously with COVID, everyone's been in lockdown for a very long period of time. So how has that impact in terms of the way Charles River have been able to support their customers and you've been able to do your role?
Well, Charles River have been able to support the customers very, very well indeed. And I think for a lot of our clients, they've probably seen, or the only difference they've seen is not having a face-to-face meeting. Everything's being done virtually. We have our COVID policies in place. We've made that very transparent for our customers and worked with them as closely as we possibly can to ensure that they don't see any difference in how our relationships and business works. For me, it's been hugely different. I wouldn't actually be in the country this week if it had not been for COVID. I was scheduled to be in Singapore this week. I would have been in South Korea last week. So my daily routine was travel. I would be away from home for something like 150 days in a year, all over the globe, from Brazil to Australia to China, India. A lot of my business would be out in Asia, but I can be anywhere, and of course that's all gone. So from March, I haven't traveled anywhere. I've been at home, and it's the longest single period I've spent at home for the last 20 years. So it's a really strange experience for me, but actually I have to say one that I've grown to enjoy. So
Good.
yeah.
So let's talk about cartridges. Before we do that, let's go one step further back and let's talk about horseshoe crabs, because obviously they've been in the news a lot. So perhaps you can explain to people why horseshoe crabs are so important and what their current status is in terms of their population and so on.
Yeah, that's I mean, they are a remarkable creature. They really are. And they're not actually a crab. That's a misnomer. They are an arthropod. They're more closely related to spiders and scorpions, which I'm an arachnophobe. So knowing that, when you turn them upside down and they've got all these legs, but actually I quite like them. They are, as I said, remarkable creatures. They've survived on this planet for over 400 million years. So they've seen the dinosaurs come and go. And I think Nicola, when you spoke to her, explained about their blood and being blue and a copper-based oxygen carrier rather than the iron-based oxygen carrier in human blood, and they have this single cell type in their blood, which inside which you have these enzymes that react with gram-negative bacteria and components of those gram-negative bacteria, called endotoxin. Their environment, the ocean, will be a soup of these gram-negative bacteria. There's also yeast and molds in there which they react to as well through a different pathway. But we've since the discovery of this ability that they have to detect and to react to these gram-negative bacteria, since that was discovered in the 50s and 60s by Frederick Bang initially, and then in partnership with Dr. Jack Levin, we've been able to utilize this wonderful gift that Mother Nature has provided and given to the crabs to ensure their survival, to detect endotoxins in pharmaceutical products. I mean, and it's exquisitely sensitive to endotoxins. We're talking parts per trillion, and there's nothing else that's as sensitive to endotoxin that we know of. Parts per trillion, that's 11 zeros after the decimal point, or a single grain of sugar in an Olympic-sized swimming pool. It's just phenomenal what nature has created there. So they're an extremely important creature for us, but also for the wider ecosystem as well. Their eggs are eaten by birds. The juveniles are eaten by sea turtles and so on. So very, very important animal. And the reason they're important to us, and the reason we use their blood, is because humans, like the horseshoe crab, we react to gram-negative bacteria as well. So what the crab does is it forms a clot to stop the ingress of the gram-negative organisms into its system that would eventually kill it. It would cause its whole vascular system to clot if it happened. For us, what happens if we get, I mean, endotoxin is everywhere. It's ubiquitous. We're surrounded by it. Gram-negative bacteria, by the way, things like E. coli, Salmonella, Pseudomonas, commonly known bacteria. We also live in a soup of it. We drink it in the water that we consume, the food that we consume. You know, if I was to swab my hand, it's on my skin. So we're surrounded by it. It's in our gut, and it's okay like that. We can tolerate it. However, if it comes into contact with our circulatory system, our bloodstream, it causes all sorts of problems. So from the mildest being fever, and then it can go right up to you know, edema of the lungs, which causes suffocation and death. So we need to make sure that all injectable drug products and invasive devices are tested for this endotoxin, and it's mandatory. So it's a mandatory requirement. So like I said, these crabs are hugely valuable to mankind, also to animals, because veterinary drug products have to be tested as well.
Sure.
But of course, they're important, as I've already mentioned, to the you know, wider ecosystem as well. And there has been concerns over the populations. Most of that concern has come through social media and activist groups claiming that what we do when we bleed the crabs, and the process of bleeding them, we hand harvest them only, so that we have fishermen that go out, collect the crabs by hand for us, they bring them to us, and then we bleed them. Once they've been bled, they're returned to the ocean alive. We do not kill them. And that process has been shown to be no more arduous on the crabs, no more detrimental to their health than simply taking the crab from the ocean, tagging it and releasing it. In fact, a study that was done recently showed that just simply taking them, tagging them and releasing them, there was a higher mortality from that than from us taking them, bleeding them, because we take all the parasites off of them and things as well. So we give them a good cleanup before we release them back into the ocean. So there's been all this concern about the numbers and the population, but the latest Atlantic States Marine Fisheries Commission report, and this commission, they monitor the health of populations of various species along the Atlantic coast of North America. And their latest report, which was published just last month, shows that the population is strong. We have a stable or increasing population in a lot of areas. Delaware Bay alone, which is where you'll find the largest single population of horseshoe crabs anywhere on this planet, is estimated there's around 30 million adult crabs alone in that area. And that's not counting the juveniles that you'd find as well. Some people have claimed that what we do to the crabs is cruel and causes them pain. They have a very primitive nervous system, so the bleeding process would cause them no more discomfort than us giving blood, probably less. And the biggest threat to them is not the biomedical industry, where you know, there is a mortality, but it's in our hands. You know, we monitor that, and it's somewhere around 3% that we see, the crabs that we take. But the biggest threat to them is the fishing bait industry. They are collected in their hundreds of thousands and used as fishing bait. Also bycatch. So they're caught in nets where fishermen are trawling for other species, and then they're killed, you know, and not returned to the ocean from that. And also loss of spawning habitats, loss of spawning grounds through coastal development. And in the Atlantic States Marine Fisheries Commission report, it clearly indicates that those are the biggest threats to the crab population. And in fact, they say that the impact that the biomedical industry has on the horseshoe crabs is insignificant.
Right. Okay.
So, you know, and that's independent data that anybody can go online and find.
Right. Okay. And Also, you mentioned Nicola's interview. So if people didn't watch it, Alan was referring to an interview with Nicola Reed, who's also at Charles River, who did a really good interview talking about the horseshoe crab population and different techniques used within BET. So if you haven't seen that, I will put a link to that as part of this video as well, so you'll be able to check that one out as well. So Alan, let's go back to cartridge technology then. So let's start a really basic question though, for someone like me who's a layman and doesn't work within a lab and doesn't work in BAT. What actually is a cartridge when we're talking about it in the context of BET?
Right. That's easy for me to because I'm actually going to show you rather than tell you. It's a lot easier to show you. But first of all, what I'll do is I'll show you what it used to be like. So
Right, sure.
Initially, when this test was developed, everything came in vials. So you had a vial like this. This is a vial of lysate. So is this. They're just two different types. This is turbidimetric. This is chromogenic. So you got vials like this that you have to rehydrate. So it's freeze dried in here. You can maybe just see the white powder at the bottom. That's your LAL, luminous amoebocyte lysate. So that's what we get out of the blood of the horseshoe crab. And then you would rehydrate that with endotoxin-free water. You would then have to also have endotoxin, which comes in a similar vial, which you rehydrate. You make up an endotoxin standard. You then have to get your sample, maybe dilute that. You'd have to make up positive product controls. And then you add all of that to either tubes, if you're doing the gel clot method, which is the simplest of the methods, or you add it to a plate for kinetic methodologies. So that's how everything was being done from the early 70s right up until the beginning of the 2000s. And in 2003, we introduced cartridge technology. And cartridge technology uses, exactly as it says, it's a cartridge. So you have this small polystyrene cartridge, and on here you have everything you need. There's nothing else you need other than your sample, because the lysate that I showed you from the vial, that's already on there. So the endotoxin that you need for your positive product controls, that's also already on there. Right. And this is set up, I don't know if you can see that there are 4 channels. Yep. On there. So it's set up to work in accordance with the pharmacopoeia, which says we have to have duplicate sample and duplicate positive product controls. So with this, there's no need for the end user to make up the standard curve, because we've done that. There's no need for them to make up positive product controls, because we've done that. So all they have to do is take their sample, dilute it if it needs diluting to overcome any interference, add a small aliquot, 25 microliters to each of the 4 cartridge reservoirs, and then set the test going. 15 minutes later, they'll have their answer.
Right, okay, so as straightforward as that.
Yeah.
So how can these cartridges, if at all, help the conservation of horseshoe crabs?
That's, yeah. What we did here, we've gone down to microfluidics. So not only have we simplified the assay as much as possible, removing many of the areas where human error and other errors creep in, but we've also been able to reduce the amount of reagent that we need. So on these cartridges, we use 5% of the reagent that would be needed if we were working with vials. Right. So just 5% of that. So, you know, put that into some sort of context. If one of our customers was using enough of the traditional reagent to require 5 liters of LAL reagent, traditionally, with cartridges, they would only use 250 mil. So it's a huge reduction in the amount of horseshoe crab blood that is required.
Right.
So it's estimated that there's about 70 to 80 million tests performed annually across the globe. If all of those were performed using cartridges, and I'm not suggesting everybody going to go out and buy a cartridge and that, but just, you know, for argument's sake, if everybody did, then for the same amount of blood that is needed to produce those 70 million, we would be able to produce somewhere in the region of 1.5 billion tests without bleeding a single extra crab.
Right,
so from that point of view, it keeps the crabs valuable because, you know, we still need them. So conservation still becomes important. And the leaders in conservation for the horseshoe crabs just happen to be the biomedical industry because they're an important resource for us. But it also means that we can use much less blood. So that's the way the cartridges, you know, positively impact the conservation of horseshoe crabs.
Right. Okay. And are there any limits or restrictions in terms of the types of samples that can be tested with the cartridge technology?
Well, there's two sort of routes on to answer that question via. So the first is, you know, from a pharmacopoeia point of view, are there any sample types, like, you know, because there's end product that everybody tests. So you've got to test your final product for release testing. That's your safety test to ensure patient safety when you're releasing the product. But then there's all the intermediate stages as well. So you've got you know, raw materials, in process controls, and so on. And the cartridges were licensed by the FDA in 2006 as a approved methodology. So from that point of view, you can test any product type from raw material in process up to and including end product, right, for final release. However, like all of the LAL tests, there isn't a one size fits all. Certain products have certain interference patterns, which means that, you know, they might not be suitable for use on the turbidimetric because they already produce turbidity, and that makes it difficult. Or they might not be suitable for use with the chromogenic. Chromogenic, we look for a yellow color development from a synthetic peptide that is added to the reagent. Right. So if you've got a sample which is already yellow or red, orange, you know, and you don't have a lot of dilution that you can do on that product, it makes it difficult to see the change in yellow color. And likewise with the cartridges, they use a chromogenic method. So if you have yellow, very yellow, red, orange samples, they might be more difficult to test on cartridges than, say, gel clot, where you're looking for gel formation, or turbidimetric. Likewise, if you have products which are very, very viscous, because it's microfluidics and we've got to draw that sample through this capillary channel, so if they're very viscous, or they have a lot of particulate matter, microspheres, those sorts of things. If we can dilute them enough, and that's dependent on their endotoxin limit and the sensitivity of the test, if we can dilute them enough, we can overcome most of these problems. But, you know, it needs testing to see. So those are the two answers to the one question.
Right. Okay. And in terms, you mentioned the pharmacopoeia. How does the cartridge technology comply with the pharmacopoeia's BT requirements?
Yeah, so pharmacopoeia sets out the requirements for running a test, and they're fairly basic. So it says that you need to include a standard curve, a minimum of 3 concentrations, and you need to run that. And it says you then have your sample, you have your positive product controls in duplicate, and then you have negative controls. So those are they list it as solutions. They say you have to have solution A, solution B, solution C, solution D. Makes it more complicated, but basically solution A is your sample, solution B is your positive product control, solution C is your standard curve, 3 concentrations minimum, and then solution D is your negative control. So on the cartridges, A and B is taken care of because you have that, as I've already mentioned, in duplicate, your sample and your positive product control. But as I pointed out, you know, that's all you've got on this cartridge. So what about the standard curve and then the negative controls? That's what we get asked quite a lot. How does that work? Well, a standard curve is what we describe as an archived standard curve. So normally, with the traditional methods, the end user produces the standard curve on a assay by assay basis. But when the kinetic methods, automated methods, were first introduced to the BET back in the mid-80s, it's actually when I started in this industry, archive standard curves were something which were advertised as a benefit of moving to kinetic methods. However, it proved rather difficult when you have different technicians all trying to use a single archive standard curve when they all have different techniques. And then variability starts to appear in the assay and it becomes uncontrollable. What we did when we developed this cartridge technology is to make sure that everything was controlled to the millisecond. So the system does all of that for us, controls everything and how it works. All of the rehydrations are done at the same time, every single time, for the same amount of time. So we have a very controlled system, which means we can utilize these archive standard curves on a very robust method. So we make the standard curve in our lab. We do that with reference standard material, reference standard endotoxin, which is the primary standard that we have to use. The pharmacopoeia says 3 concentrations in at least duplicate. We have 3 concentrations, but we have 10 replicates instead of just the 2. So we exceed their requirements there. They also say we have to have linearity of, in absolute terms, of 0.980 or better. We shifted that up and said, well, for us, it needs to be 0.990 or better. So we exceed the requirements there. And the pharmacopoeia doesn't say who has to run the standard curve. It just says one has to be included. So it's an archive curve and it meets all of the requirements. And in fact, the 1987 and 1991 FDA guidance documents also referenced archive standard curves. So they're an FDA approved method as well. So we meet that requirement for the standard curve. That's there. Every batch has its own unique standard curve. When we produce it, we also test it for accuracy and precision. So it's not only, prepared, yeah, that's good, it meets our criteria, that's enough. No, we say, now we challenge it. So now we test it to make sure that it is accurate and it is precise. So our customers can have a great deal of confidence in the curve that we produce and that they get with their cartridges on their certificate of analysis. So that's that side. Then you've got negative controls. And yes, it's true. We don't put a negative control on the cartridge. And there's a good reason for that. And again, you sort of have to go back in time for me to explain the reasons we have negative controls. I'm going to say fortunately or unfortunately, I've been in this business for over 32 years. When I joined, it was just a job. I didn't realize it was going to turn out to be a career, which it has been. But negative controls were there to ensure that the water you use to make up your endotoxin standard curve wasn't contaminated. That's something that's been lost in the mist of times. People seem to think that your negative control there is there to make sure the water you've used to rehydrate your sample isn't contaminated. But that doesn't matter. If your sample is contaminated, you'll get an out of specification result, what we call as OOS, and you're supposed to investigate to find out why. However, if you contaminate your standard curve, what you do is you change the slope and the intercept on it. And if the slope and the intercept get dragged down, which would happen through contaminated water, you can run the risk of underestimating the amount of endotoxin you have in your sample. Now that's important because underestimation is the worst case, because that means you could release a product that has more endotoxin in it than you think it does, which then raises patient safety risks. So that's what the water was there to do. Now, as I've already explained, you don't have to make a standard curve with the cartridges. That's already been done by us. So the only thing you're using the water for is to dilute your sample if your sample needs diluting. Now, if you do have contaminated water, your sample is going to fail. You follow the procedures, run an investigation, you test the water on its own, you find the water was contaminated, you've reached root cause. So it's what we would call fail-safe. So not having a negative control on there doesn't put you at any more risk than having a negative control on a normal system.
Right.
In fact, I go in labs and I see people, what they do is they take a fresh bottle of water to put out their aliquot out their negative controls. So they have no traceability whatsoever between the negative controls and what they've done elsewhere on the plate, which should be a complete no-no. You've got to have that traceability to ensure that your standard curve has not been contaminated, so that your sample, accurate, you've got an accurate result for your sample endotoxin value. That's what we do. If customers, because there are some that still want to include a negative control, they feel, it makes them more comfortable that they've done that. So they can always test the water at the start of the day or the end of the day, or as the FDA, an FDA spokesman suggested back in 2012 at an endotoxin summit that he was speaking at, said test your waters on an incoming materials basis. When you get a new batch of water, endotoxin-free water in from your supplier, you take samples, you test those samples as part of your incoming materials control process, and that covers as your negative control, so you know your waters are clean. So that's how we meet those requirements, and yeah, it meets all of the pharmacopoeia requirements for a bacterial endotoxins test as per the chapters.
Fantastic. Right, so if people want to know more about this topic, where can they find out more information?
You can go to our website, so that is criver.com, so that's C and then river, all one word, .com. You then have to go to, I have to remember this myself because it's a bit convoluted. You go to something on the, I think it's solutions, then you come down and you find another tab, but eventually you'll come to
Don't worry, viewers, I will find the link and I'll put the link on there so you don't have to go through that process. So we'll just have the whole link up there on the
Yeah, sorry, talking over. It's great. I was going to say, when even people from Charles River can't explain how to get to the.
No, don't worry.
Right.
To make it easy for viewers and for you, actually, I'm going to put the link on the video, just above the video, so you can go straight through and find out more information. So, Alan, thank you for taking the time out to talk to me. That's a very in-depth conversation we've had, covering everything from the horseshoe crab population and why they're important to obviously the use of cartridge technology and how that helps people, not just horseshoe crabs, but more importantly, how people can use that for BET as well. So thank you very much for going through all of that.
You're welcome.
If you'd like to know more from Alan, then please leave a message below in the comments, because I'm sure Alan will be happy to answer any questions you've got, if you've got any, or you can message him directly. And as I've already said, the link for further information will be above the video. And also there will be the link to Nicola's video that we talked about a little bit earlier as well, if you want to know more about some of the other aspects of horseshoe crab population and other parts of BET as well, which Nicola covers in her interview. So all that stuff for me to say is, Alan, thank you for taking time to talk to me this morning. Very interesting, as always. And actually, for those who are wondering what that noise was in the background, they were seagulls, because obviously we're by the sea, and so we were interrupted every now and again by a few schools of seagulls. If you're wondering what that noise was, that they were actually seagulls there. So that it was good to have the seagulls come in with a bit of background noise as well.
They're a bit of a nuisance, I have to admit. So they nest on the roofs of some of the properties around here, and they can be very noisy at times.
I can imagine. Well, look, thank you very much for taking time out. As I say, have lots of success staying at home
Thank
and
you.
going through the cold turkey of not traveling. I know what it's
Yeah,
like, actually. As I said, I've been traveling every week as well until lockdown, so I know what
yeah,
it's like. But yeah, and hopefully, things will go well, and we'll catch up in the near future. And until then, for
yeah.
you and everybody else watching, as always, stay well and stay safe. Bye bye.
Thank you, Rizwan.